In this video, we're going to be walking through a transistor circuit again, but this time it's going to be a little bit different. We're going to encounter something called saturation. Now, the best way to describe saturation is to actually walk through the circuit, and so we're going to follow the exact same steps we followed in previous videos on transistors. The first thing we're going to do here is we're going to assign some values. So we're going to deal with a 48 volt source. We're going to have a 15,000 ohm resistor there at our base, and we're going to have a 350 ohm resistor at our collector. As with every other transistor circuit we've worked with, we're going to take our VCC minus the 0.7 volt drop that we get across there to get our VRB, which in this case will be 47.3 volts. Again, just like we've done in every other transistor circuit we've worked with. Now we're going to get our base current. How do we do that, you ask? Ohm's law. 47.3 divided by 15,000 is going to give us our answer of 3.15 milliamps. Let me just get my little pointer out of the way. 3.15 milliamps. Next step, just like we've done before, we take our base current times our beta. In this case, it is 75. We multiply them together to get our collector current. In this case, that works out to be 236.25 milliamps. All right, so far you're saying this is exactly the same steps as we've taken in all the previous videos. That is very true. This is where things get different. What we're going to do now is, like we've done in every other video, is we're going to take our IC and multiply it by our RC to get what's known as our VRC. Again, not too different. We do that. We take the current of 236.25 milliamps, we multiply it by the 350 ohms, and we end up with an answer of 82.7 volts. Stop right there. This 82.7 volts is larger than 48 volts. We're not just making voltage out of nothing here. At this point, we say that the transistor has become saturated. It has got more voltage on the RC than it has available to it, which is impossible. Now, there's a few points to make in saturation. In saturation, when we get to the point where you've calculated out your VRC is larger than your VCC, you stop right there and you say it's saturated. Then, in saturation, the VCE is 0.1 volts, which is fairly small but significant, because what we're going to do again is, using Kirchhoff's law there, we see that on this branch here that has to equal 48 volts. So that means that if this is 0.1 volts, this has to be 47.9 volts. And we're done. When you encounter saturation, if your VRC is larger than your VCC, then you say it's saturated. Your VCE becomes automatically 0.1, and then your VRC becomes VCC minus 0.1 to get your VRC, and we're complete.